Okay, so the product property, split it into the sum of two logarithms. The quotient property, what do you think it's going to do? If multiplying and dividing go together, adding and subtracting go together. So what the quotient property does, and think about it, remember logarithms are very closely related to exponents. So think about your exponent rules for a second. When you multiply like bases, what do you do with their exponents? You add the exponents. When you divide like bases with exponents, what do? You subtract their exponents. So that should kind of make sense to us, okay? Make that connection here with the logarithms. You know your exponent rules, so your logarithm rules are very similar to that. So if you're dividing within a logarithm, then you subtract the two logs. Okay, what's up? Thank you. Thank you. All right. So let's look at number 7. Log base 3 of 24 minus log base 3 of 8. I keep on emphasizing this. The bases have to be the same. Okay, the bases have to be the same to be able to do this, which they are, so it's not a big deal. Okay, so they're both base 3, so we divide 24 divided by 8. You do it in order. The number that came first is on top. The second number is on bottom. What is 24 divided by 8? 3. And what is log base 3 of 3? Think about it for a second. That says 3 to some power is 3. The first power, okay, 3 to the first power is 3. Anything to the 1 power is itself. So we started out with something, log base 3 of 24 minus log base 3 of 8. We couldn't have done that without a calculator, but using our properties of logarithms, we were able to put them together, and then it turned out to be something that we could figure out the answer of. Who would have thought that that would equal 1? Okay, let's look at number 8. Log base 2 of 15 minus log base 2 of 15. Now, does that look weird to anybody else? What do you think the answer to that is? 0. You're subtracting something from itself. It's 0. But again, let's say that you're on the whole properties of logarithms idea, and you go and you divide, and 15 divided by 15 is 1. What did I tell you the log of base anything of 1 is? 0. Anytime there's a 1 in your logarithm like that, the answer is 0. Okay, so same answer. Okay, whether you catch it at the beginning or whether you go with what we're learning, same answer. Okay, number 9, log base 4 of x to the 9th minus log base 4 of x squared. Same base, so we can combine them into a single logarithm. We are subtracting, so we divide x to the 9th over x squared. How do we simplify that? We subtract those exponents, so that is log base 4 of x to the 7th. Log base 4 of x to the 7th. Okay, let's look at number 10, log base 8 of 4. Log base 8 of 4. We want to expand this, so we need to turn 4 into a quotient. Okay, we need to turn 4 into a quotient. So what two numbers can we divide to get 4? 8 and 2. I like 8 and 2. You know why I like 8 and 2? Because our base is 8. And since our base is 8, the log base 8 of 8 is equal to what? 1. Anytime the base and the number in the logarithm are the same, the answer is going to be 1. Okay, anytime the base and the number inside the logarithm are the same, the answer is going to be 1. And guess what? We can technically figure out log base 8 of 2. Okay, what's the exponential relationship between 2 and 8? 2 raised to what power is 8? The third, okay? So if 2 cubed is 8, then the cubed root of 8 is 2. We did one of these a second ago, so log base 8 of 2 is equal to 1/3. And 1 minus 1/3 is 2/3. Kind of interesting there. Now, it's okay if you didn't take it all the way to that point. If you were doing this problem, if you could just figure out the quotient part, that's good. Okay. All right. Log base 5 of 1 over 3. It's already in quotient form, so let's just split it up. Log base 5 of 1 minus log base 5 of 3. What's log base 5 of 1 equal to? Log base anything of 1 is 0. Okay. And we can't figure out a relationship, a whole number power relationship between 5 and 3. So really this is just equal to the negative log base 5 of 3. Okay. There's more. Okay, thank you. Okay, one more here with our quotient property. Log of m divided by 7, so that's the log of m minus the log of 7. And there's not really any simplifying to do there, okay, because the base is 10. 10 and 7 don't have an exponential relationship. We can't do anything with the m, so we just leave it as it is. Okay. Questions about our quotient property there? Questions about that? Okay, we got one more property here. We got to talk about our power property. Okay, we're going to talk about our power property. So if there is an exponent inside of a logarithm, so for example, we've got log base b of m to the nth, what we can do with that is the exponent comes down as a coefficient in front of the logarithm. The exponent comes down as a coefficient in front of the logarithm. So that n comes down in front of the log. Okay, so number 13, 5 times the log base 4 of 2. We can go the other way with that. If there's a number in front, we can make it an exponent. Now, what is 2 to the 5th? 32. Okay. Let's use change of base to work this one out, because I can tell that there's a relationship going on here. We can't raise 4 to a power, a whole number power, and get 32, but we could express both of those as base 2. So let's use our change of base to see if we can get an answer for this. The log of 32, closed parentheses, divided by the log of 4. 2.5, which is 5 over 2. Okay, 5 over 2. Okay, number 14, 7 times log base 2 of x. We can move that 7 to become an exponent on the x. And that's all we can do, okay, because it's an x and there's no number that we can simplify, so that's all we can do with this one. Okay, 1/3 times the log of 8. We can move that 1/3 to become an exponent. Now, I've talked about this a little bit. The 1/3 power means the cubed root. So what's the cubed root of 8? 2. Okay, it is 2. And there's not an exponential relationship between 10 and 2. So we just leave that one the way it is. Now, if the 1/3 thing is still not making sense to you, just type it into your calculator. Okay, just do 8 to the 1/3 in your calculator. And it'll spit out 2. If it doesn't give you a whole number, then just leave it the way it is, okay? If it doesn't give you a whole number, just leave it the way that it is. Okay, so now we're going to go the other way. We're going to expand. Okay, so we're going to move exponents in front of our logarithms. So number 16, log base 2 of 8 to the 7th. We're going to move that 7 in front of the logarithm. And log base 2 of 8, can we evaluate that without our calculator? 2 to what power is 8? 3. And what is 7 times 3? 21. So who would have thought when we started this problem that the answer would be 21? I wouldn't have to. Not right off the bat. Okay, let's see here. What do they want us to do with this problem? We need to move that exponent in front. Now there's already a number in front, so we just multiply it along with that number. Okay, if there's already something there, you just kind of stick it on the end of it. Really, that's all we can do. We could distribute the 3, but there's not really a point in doing that. I would just leave it like this. And just leave it like that. Now, number 18, we got to do a little something before we can use our properties of logarithms. We've got to make that square root a power. So hopefully you remember that the square root is the same as the 1/2 power. That was a math 2 thing. Okay, the square root is the same as the 1/2 power. And so then we can move the 1/2 in front of the logarithm. So we get 1/2 log base 7 of W. Okay, so before